This is the MSD RAS program, part of Stuart Weitzman's School of Design in the University of Pennsylvania. This project is for ARC 801's Material Agency's Robotics and Design Lab 1, and this project is conducted by Adityan, Chem, Horia, Amber, and Sihan. Antoine Pevsner and Naum Gabor are considered pioneers of the 20th century sculpture. They are designers, painters, and printmakers as well, pioneering kinetic works that assimilated new materials such as nylon, wire, lucite, and semi-transparent materials such as glass and metal. Gabor rejected traditional sculpture techniques of carving and molding, instead using processes closer to architectural construction, building up his sculptures from interlocking components. Rule geometry was key in their design. We analyzed Gabor's linear construction in space number 1 and number 2 sculptures, which was of kinetic art. Some of the geometric qualities we discovered about our sculpture was the materiality and how it created an illusion of curved surfaces through different dimensions. We decided that the linear construction in space number 1 would suit our design intentions better, so we did our own variation of it and implemented techniques of the present form. Linear construction in space number 1 was constructed from 2 distinct materials, which perform different functions. The Perspex frame, made of 5 pieces, provides a skeleton and describes as one form. The nylon threads act as the sinews drawn around this frame, creating an illusion of continuous form with subtle light and shadow effects. Both Perspex and nylon were newly invented materials back then. Our perception of the geometry changed after it was transposed to the foam block. While we were able to see shadows with the renderings we created, they didn't have the depth of natural sunlight hitting the roll surfaces, casting a beautiful shadow caused by the tooling we had applied. We got to see how foam cut by a hot wire had different effects on the texture of the final model. Cutting the geometry was an important step in learning how to use a robot to cut foam using a hot wire cutter. We saw the limitations of the robot as its joints are not able to twist and turn indefinitely in order to do one complete cut for the whole model. Overcoming this required planning and strategic subdividing of the model in order to combine the cuts we needed for our final geometry.
We utilize convolutional neural networks to create singular topological composition. The CNN read the light and shadow in our initial collage of our tooling in a way that we can read as ruled geometry. The CNN was able to generate a new section and redistribute the form and refresh the tooling. The GANS method was successful in keeping the ruled surfaces and our tooling methods consistent with our original model. The wires Gabor positioned in his artwork gave an illusion of curved surfaces surrounding an oval void. The GAN hybridized these features and added different background layers visible behind the new voids and depth, which is also visible in our final ceiling proposal.
The micro-relief tooling was an essential configuration to our overall geometry. We implemented the micro-relief tooling only around the hole in the ceiling. When it comes to the surface where each hole connects, the tooling gradually disappears and the surface still keeps the original smooth appearance. With the change of the ceiling surface height, we can see the tooling not only on the front but also on the sides. In this way, we can see the ridge line and shadows change and the transition of micro-relief tooling from all angles. Our geometry generates from sweeping lines and hyperbolic parabolas. We apply the generation principle to the whole ceiling, while the proportion of chosen area that best reflects the generation principle is displayed as a ceiling detail.
Along the hyperbolic surface, there is no corner or focal point, so a more decentralized and democratic part-to-whole space arrangement could be derived in large-scale applications of hyperbolic surfaces. We believe that this showcase would produce an immersive experience for the viewers. The goal of the design was for all visitors to sense the regularity of the changes, the rhythm of the construction, and the impression of space beneath the ceiling.